Okay. Looks like we are.
So this is the participants. So if anybody joins and is not on mute, force them to be on mute. And if anybody's chatting and asking questions, you can just wave and tell the presenter if people are coming in. Okay. Okay. Everything good?
But anyway, we're 7 minutes of this. The title of this tutorial is Platform Computing and AI. Yeah. And the in the first
My roommate is presenting.
first slide is actually I landed this one from AI to type of AI. They are also a huge number of GPUs, right? The size of GPU in kind of policies as AI phase. They are focused on the phase, H100. I believe you may know for H100, H100 and B200, something like that, right? That's kind of type of data GPU. Then the policies is kind of say, have a 20K, 200K, sorry, 200K HS. It's this side, right? And also those something called target talking, so much bigger or the processing thing. Also, the company and media is talking about some term called AI factory. They are saying, hey, this kind of AI data center is playing like the role of factory because you have to support the tokens you generate through this factory, and then then you can really watch or you can play with the AI. So the concept of AI is now changing. It's not so kind of the it's more about the industrial applications. Yes. So every here talking is there in Korean situation. Government's talking about the 10,000K GPUs. It's just allocated for public and support. Then they are talking about the pipeline of this size. Yes. And then maybe more. So the number of GPU have to be kind of a big to support users are now really big. This thing and also related to some kind of say notion or trend called exponential age. So if some countries going to into the curve, right? The inspiration of this huge size GPUs or AI infrastructure means okay, the kind of say if someone is going and ahead of you and if they are speeding up, then you cannot follow because the speed of kind of say innovation or speed of kind of say transformation is so fast that followers cannot, you cannot kind of reduce the gap. So that's kind of thing. So that's why all countries are now trying to push, to build AI as much as they can. Looks like that's kind of makes sense.
Showing
The government is really trying to push this direction also in the same reason. Okay.
I don't know what he did, but
So
it's showing just the chat.
this thing about the scale of AI infrastructure, right? So then the term hyperscale usually came along, and also the Gen AI, right? Generative AI is kind of how we are hearing every day. Also the foundation models. So Gen AI and foundation models. So the size, let's try to check the size thing. The size can be big, right? So we may have things this kind of size. So this blue line and this green line talking about the exponential growth of the change. Yeah. It's looking on the CPU power needing to build your models, your foundation models, or like a GPT. So you have to have huge size, huge number of GPUs in order to support them, but they are okay. This is exponential line growth, like the linear line means that it is exponential growth. So that's big thing to us. Also, okay, now some people they say sensitivity 4 and 4.5 and 5. So OpenAI is suffering because their release of GPT-5 is kind of delayed. So they are saying it's almost ready. But the trend is the number of the GPUs or the number of training hours has increased a lot. But some say, okay, it's kind of close to saturation. No, this still can be larger, okay, anyway, the series continue.
6, 7,
Still, it's collective of the speed of change or speed of size is expansion is kind of a little bit slowed down, but it's keep increasing.
C's.
Okay, so enjoy.
Okay,
So,
wait. He
so
did
anyway,
make that one.
now I keep
When
saying,
I
okay, the
joined,
number of
I need to
issues
was
and the
doing
training takes a lot of
Yeah.
data, a lot of computing power, and a lot of
Someone-
interactivity here.
1 second.
Very hard. One more thing is to under this time, you may heard of different speed, different kinds of
Open
scaling.
it. Click.
So
Click.
GPT and GPT generating a pre-train, right? That pre-training is kind of one pre-training and scaling problem. Then they are now
One
saying
member.
post-time,
Just this
the
one.
post-train.
I think something is not working for me because the remote people are unable to join. Because when I joined, the screen displayed my name.
All these reasoning times, if you think more and more about the sometimes they give a pattern, you will answer better, right? That's the reasoning skill. So pre-training scaling, post-training scaling, and test-time scaling is kind of a method for this. So you may check around the distance. But here, the foundation, let's go to the issue of foundation model. That's the role there, so people say LLMs, right? Huge size LLMs. Okay, they will play the foundation. Foundation means they have the power to be
I
basic
think something
things,
is
so
not right
you are
because
ready,
it's not
so
even
you have
recording.
basic skills already,
showing.
so and you are given for some
9,
specific
6
more
minutes
additional
started.
information for some specific topic, then you will learn it very fast and can be an expert. That's the sense. Foundation model here, foundation model is kind of very trained for all basic things, right? Then if you just adapt it to some given target environment, then it will become expert. So the sense of foundation model it can be analyzed as multi-talent. This foundation model is really huge, but still very powerful and multi-talented. It's different type of AI models. There are two types. In this sense, can you see the AI model? There are two types. One is foundational huge size LLM oriented. Now they are also becoming multi-model, but they are there. And also the other type of AI models are kind of skills worker type, can do this thing, yeah,
It
very
changed.
well. And yeah, these two type of AI models are now used and they are working together, right, for us.
Select.
Okay, so the sense of foundation model, I believe, you have it, yeah. You already know about it and then probably you can test it. Another one is AI models, right? They are going into, the OpenAI talked about the O series, right? So, O1, O3, and the 4 is different, yeah. O1, O3, all these reasoning
Here it
conditions.
is.
So that's
Just
what
showing
we
you
use.
the card.
But
So I think it
if you
should
go
be
in
this way.
there, let's
That
see on the
way someone
top
will get to know.
maybe one more. Okay, then you are working with this very huge size AI models. Okay, large scale language models, for example.
What's happening?
Then
Because I
how
joined as a member,
are you going to
as a
utilize?
participant.
How are you going
My
to this
name got
huge
displayed
size?
there. Like
Okay, the model is too
the
huge,
entire
it takes a
screen.
lot
So I
of
exited the
money
meeting immediately.
train, time and money
And
and
then
all
thinking
those
about
things,
it.
right? The only thing you can possibly do is you can only fine tune it a little bit. Okay, this is my, can say, my data, to check and then make yourself ready to answer question. They checking this specific additional information is fine tuning of your models. Your model is already trained for all basic things, and this fine tuning is something you may be able to do. But this fine tuning is also sometimes taking some money and effort because of the size of models. That's one thing. The other one is retraining. Okay, this foundation model is not really working for me. Maybe some cost, okay, some change is required. But okay, this one is really huge investment. But if you really want to do that, you have to do retraining. But this is not an easy game. And also you may heard of a lot, right? Yeah. So retrieval augmented generation is a kind of say the method. So filtering to other material and then kind of say, yeah, the generation of LLM is becoming more customized. These three types of usage. So simple three type usage, everything except for lab. Lab is more say, yeah, not really trying to retrain or the cost of say original models, but they all of those, yeah. Okay, the degree of change to original model is not is minimal. It's almost nothing because you will do something you know to utilize the model given to you. Then fine tuning is kind of touching onto it. Yeah. The surface of the model kind of. Then retraining, you may touch some portion, but it's not everything there. Okay, different type using different type of computing, yeah, effort. Yeah, let me say. Another trend, since there are so many models, right? So many models and LLMs. So now people are talking about the agents. So AI agents is really big topic, and then agent-based AI services are coming out. Yeah, OpenAI also just kind of release their agent-based AI service. This means agent AI will be in the middle of us and the AI models. All these AI models are there, they are here, the middle agents. Because we don't know which model is more best for you. So then some of course will kind of say AI experts around you, they are like multiple AI models. Yeah. So GPT and Gemini and other cloud. So mixture of those. But you should be there, you know, to select. So that's happening now. So, but if you have some kind of agent who can play that business match role for you, that will be better, right? So agents are really becoming hard, and then everyone is saying about it, multi-agent is support. So that's another trend. And all these things is talking about, yes, huge size of AI infrastructure, and because of the demand for foundation. Yeah. Okay, this foundation work, maybe in the Korean context, Korean government is talking about sovereign AI. Okay, should we have this one LLM for our country, one or two? Yeah, kind of say all. Yeah, that's a big issue. But so for our decision is that we need to do this. Yeah, some sovereign AI LLM for the country. Yeah, that's what kind of decision and some push is going on there. So the sense of kind of say infrastructure and platform and kind of say services utilizing those, the sense of those that to me this way. So I like the term called the DNA. Let me explain that one. D stands for data, as it is. Yes. N means actually networking, and A is AI. Data will be linked to AI. That's what we're trying to do. So AI models, they will consume data, right? Accumulate data needs to be provided. How? Okay, you have to have the infrastructure. So and that's talking, okay, that's talking, how is supporting N? Yeah, as you can see, we are cloud working, right? Cloud is supporting the role of N networking. So can I say DNA? Yeah. Data need to be networked through AI, so then we can utilize. So that's the sense of DNA here. To the data, so pumps are now there. Okay, warehouse, yes. is what they are lake, and now they are also talking lake house. Then combine this sense of lake and a lake house. Oh, sorry, lake and warehouse. So lake house seems very much interesting one. So I also working on some a little bit on that lake house thing these days. Anyway, data, right? Then our cloud-based infrastructure, when I see cloud, okay, the sense of cloud to me is kind of huge engine-based with computers. Engine stand for Linux, then almost Linux, okay, most cloud are relying on Linux operating system, right? The sense. And as well as, okay, so there are different type of clouds, but one kind of interoperable cloud is cloud native cloud. So CNCF based Kubernetes. So that's the thing very much important because we are kind of say users, so we don't want to rely on specific kind of say cloud service providers, right? We don't want to rely on soft. So push forward via cloud native one is really growing and it is keep increasing in a sense. Okay. So data and cloud-based networking, then AI will grow, right? AI models, they need to have input, data input, then they can grow, right? So then once they are grown, the models can be utilized to support your AI leveraged applications and services. Okay, that is kind of DNA concept. Then can you think of this thing, then can you really want to utilize this AI power for your country's economy or maybe society? What is the basis? The sense of those places, you may think of the world as a kind of infrastructure, social, societal, or public capital, right? Some people the SOC, the different version of the SOC with this kind of being there, it's really centered around cloud. The cloud will be sitting as a kind of say base camp to all those services, and then things are spread out. Secure cloud means really big size data centers kind of base, and then it will go through edge to the end, right? The sense of the edge to kind of I personally call it this edge to access cloud listing. So all these edge points, yes. Here in this kind of hotel or restaurant, we can call this an edge point. Then there will be some cloud accounts to support us. That sense is very much important. To me, the world cyber infrastructure changing into, yeah, or kind of transforming into this kind of shape. Okay. And let me move on. Okay, so I first been talking about this thing. Okay, we are now working on this cloud native and data centric infrastructure platform here. Let me try to say define one of the clarify cloud native. What is cloud native cloud? This kind of this open source Kubernetes orchestrated containerized applications are here. Okay, this containerized applications also those AI models for the usage of it, to utilize the AI models. So the containerized say kind of talents, containers ones are there. You just take containerized AI inference models and you try to utilize, right? So the sense of use when you're using it, okay, the inference model is already containerized. You just take it and use it. Okay, that's the sense there. So I explained about how they part and then data center. Okay, so data needs to be there. Then how can you really kind of gather and accumulate and share and exchange and utilize it? So we do need some infrastructure focusing on that one, but that thing, the data infrastructure is still not fully ready. Okay, from the viewpoint of hyperscale cloud, they have infrastructure for data support, but unfortunately, for all others, okay, you may have your own small data island. Okay, so kind of, when you want to utilize it together with the other type of data, maybe in your country, who owns it, how to share it, the rule is not there, and it's not mature. So it's not really happening. It's really big obstacle utilizing data together. Okay, so data center infrastructure is not there because we don't know how to really exchange data and utilize it. So in some scientific domain, yes, things are much better because some collaborative science has to be there, and then they set some rules for all this because they need work together for scientific question. Okay, there things are much better, but in all other areas, still, when you are working with this domain data, you should work this way, another domain, another way. Everything is kind of separate. Now, because of AI, because they need data, things are getting around this, but still, this beginning stage. So data-centric chemistry, infrastructure change or platform change is still in the beginning phase in some sense, and people are talking about data platforms. Data platforms to be there for data management. Yeah, platform management, they are growing, but yeah, still they need to grow a lot. But one thing which I want to mention today, actually, this is like I put in some effort for something called OTF, Open Table Forest, and this is something called iceberg. Yes.
There's no
Okay.
participant
Have
in
you heard of this thing called iceberg? Some metadata related the data organization tool, maybe open source tool. Okay, I will talk a little more on this, but the sense of annual optimal data. Okay, the term I prefer is to say warehouse, right? Because the sensor warehouse and the data lake is combined into warehouse, then here, can you have your warehouse, how your data will be located. So if you look at some kind of say, okay, let me go into supermarket example. Then you go to supermarket, all those groceries are there. You can easily notice what is there, right? They are all available, so they can be easily consumed. But if it's not there properly organized and put into pieces, how can you select the one you like? But still worldwide, the data grocery is not really the supermarket style one. It's more in, say, traditional market, all these, traditional market, things are there. It's still organized one by one. If you put it put together, everyone has their own style of, say, showing the groceries, business data. Anyway, okay. So I mentioned about this thing, and I already mentioned the cloud native connects thing is true. So
I think you can do the same.
this kind of say the state is something that really talking a lot. Okay, let's look at this. State AI needs to grow over data, right? They need to consume data. Okay, data needs to be accumulated and you change. Okay, but are we ready for that? No, not yet. Okay, for the cloud side, the your infrastructure is modernized enough to support containers very easily. That is kind of the cloud native when it's operated one. Still, world is going forward. Still, it's not really faster. When I say cloud native cloud, it is very much faster one. Yeah. So anyway, cloud native data centric, and then I have
there's
this
no
kind of
participant
say
in this meeting.
yeah.
And it
So
didn't show me that it's
if this shape is very interesting, so in one side, the other side, I open data analysis, doing a data analysis. Doing a data analysis. And in the center, the sense of AI speed. So when we think of AI as a computing, the training and inferencing, if you point it and check it, you see these two things are getting together here, right? So and computing it. Also all these large scale LLMs, right? and you want to optimize. Then if you go into the models and LLMs, the training time takes too much, or the inferencing is becoming bigger and bigger because the models have become larger. So the inference also takes time and effort. If you want to reduce it, then what should you do? So faculty rate, you can say the optimization is really getting there and there. Okay. So looks like I need to talk to the sense of please remember this tracking check is really important because all they share data, they all together, right? They all these three things are working together. Okay, so okay, let me just get this cloud native technical slide. So everyone knows containers, everyone knows Docker, interact, and so right. So let me skip this one. And also, can I say data centric? So the sense of data centric, how do we support, let's say, accumulation of gathering and accumulation, creation, all these things. So I mentioned the rate cost, right? As a kind of say maybe idealistic kind of say place to, but what you want to do is actually you want to store data, right? Okay, you need storage, but that storage needs to be connected. So for that one, I mostly using the term called connected data rate. So the storage should be well connected so that the data sitting inside will be easily move around. So that is connected data in the concept. Then over that one, how you are really trying to do these days? You want to have this data here, another time data there. You want to mix them together, utilize for your data analytics service, also for your, let's say, AI model training. So you need all this data, right, to train your largest language models and beyond. So then still the infrastructure is not yet okay. Also, let me just point out this thing, all this LLM kind of say builders, like say OpenAI and the Mac and the Google, they say, okay, the data, they kind of consume the data existing in the world. Then they are now relying on artificially generated or augmented data. Because the data sitting in the world is almost consumed. They need to feed more data to for their next version of LLM. Then it's not there. So generation of data, artificially augmented data is kind of tracking them to grow, right? So that's the situation. So, okay, I have several slides for your talks, but since we're consume time, let me just say, can give us a the sense of data is also not really precise. Okay. I realize if not really can say sense the data in this multimodal way, all these human sensories, so kind of say the view and hear and the taste and then smell and thought right? Then those are there also attacking. So when it is there, also individual, right? Then the sense of people's understanding about data is data is not just price and nothing at all. Data is really complicated to kind of say animal, really just for it. And it's really hard to understand and manipulate. Yeah. So okay. Also the sense of this, all this data, huge number of them is required. And then we have talked a lot about big data right? But the main issue is all this reliability and challenging. Because we want to train AI models, we need to make them ready to be consumed. Really, let's say, clean and reliable data is not really sufficient enough. everywhere, everyone who's trying to train their models, they are suffering of this problem. Yeah. And also, when the situation changes, you have to have a new data, right? Then you have to match it. Your model has to be retrained or kind of continuous trained to match it. So training and influencing all the data relationship is very much complicated, very much infinite. So the solving this relationship properly is an issue. Okay. Okay, the big data thing originally they came from this, yeah, the Hadoop thing and then Hadoop and then Spark and you know those ones are still going and they grow. The structured, essential, unstructured, and you know, up to the lake house and up to the column, key value, and those things, right?
They're
The
sharing
data
ours.
tools has also has weakness about so a lot of say progress. Still, because of all these diversities, and still very hard to understand. Because I personally kind of say, focusing on this data problem more or less 5 or 6 years. I was not really data people, but still very hard to understand or everything. Yeah. But since kind of getting sorted out, well, that's good news to me because I mentioned about something called open table format, iceberg thing, the metadata is now become open source. It's not really standard thing, but they are gaining momentum like the Kubernetes, cloud native. That is really good news for me because then if this trend is continuing, okay, what you have to base the kind of the format will be prevalent, then okay, something important is something called object like iceberg, like the data analysis company or something called Snowflake, you may heard of the Databricks, and all these storage vendors, they are now supporting this iceberg. Iceberg format is kind of say becoming really central, they are taking central because in topology also when you are doing your air model training, you want your data ready to be consumed. If you work in one domain, your data without OTF, it will be kind of property thing here, right? Then you have to convert it to utilize and convert it. So it has so much effort. Also, storage infrastructure and the data management, the data platforms, software tools are not ready. But if this thing called OTF gain momentum, things will be become different. Since we get much more interoperable, this metadata oriented open table format will play some important role for us with the term like the data lakehouse. Okay, this is a slide talking about data engineering, science engineering is very much data, working with data, making it ready to be shared. It's really challenging thing. It's kind of slides explain that. Okay. So data need to be and security to AI, that's concept. So then there's a sense of data actually, since even if we are working on hybrid networking, still some places, and even inside Korea, we do have to kind of say, hard drive, yeah, bring it to the center and then utilize it for kind of type of computing service. Still, that's happening there. Okay. So when we talk a little bit about some kind of experience I have around this one, I actually running kind of start learning some APAN60 computer for Dream AI. The name of this cluster is Dream AI. So kind of it has a lot of type of computing and AI converged open infrastructure. Yes. So I like this shade. I still so still take the name of our computing center and then and so kind of different kinds of building kind of thing. This computing supercomputer in a the sense which I had is like this. Okay. So that time, 5 or 6 years ago, okay, the OpenStack and the Kubernetes is Kubernetes has that momentum and the OpenStack was more relevant, but it's not a little for power and anyway. So data is the bottom side of that, right? Infrastructure management side. Then this thing has grown a lot. This thing has grown a lot, and this means so this thing is included kind of AI data will be shared out. So other things containerizes once and all this AI transports those actions. So and one production say 5 or 6 years ago, 10 years, give a chance of a big computer or can say 5 hours. Size is $10 million thing. Okay, so the choice which I had, I said high HPC, high thin AI, right? High computing AI together. But that time, we have tendency try to incorporate one HPC, strong HPC as much as the business containerized support. So kind of successful cooking that to some extent. But at the same time, when we are operating this kind of infrastructure, we also have to say OpenStack thing. So VMA, we can say multi-purpose node to support like say support all this operation of this cluster. So then OpenStack and Kubernetes can be defined for this infrastructure and so then different roles and different configurations to the happen, then that was okay. We originally wanted to figure this thing last machine of naturally, but that was not easy. I realized the tool was developed and the passive, but in a really transforming something as a node from one to another. It is not an easy thing. Yeah. Anyway, so we have some lessons. Okay, it's global, but each requires its own time.
It's disrupting there. You're changing the screen.
Okay, this is our machine. So, and we talk a lot about the operation now. I have 3 years of experience for learning this infrastructure. Because originally this is a 500 and then the outside condition is can say we have 100 connection to outside, yeah, and also
This view.
amount of energy consumed is still we actually confident that this edge data center we call it smaller size data center, but it's making also this kind of green into energy efficient with some effort to containerise contained and so on. A lot of effort has been put. Then still our
See how
field
it's
is
pause.
it's not a
That means
very
it's
number,
recording.
but anyway, since here.
If it says pause.
It was about the dimension of the power, right?
Yeah, it should be able to.
But we didn't
Just make sure you're set.
we have some loop over here having some wrong with it. Anyway, the buildings and infrastructure, building security,
If you join up and see.
very carefully designed this part. And this thing, and this is can be very laid out, the containment thing. And I don't want to beginning this journey for installing okay,
which is
the server thing, right? Then when it's found that we were kind of lucky to kind of make it happen, and there was not any single problem happened. Yeah, it was the longest most for last 3 years. And this thing is going into another extension of technical capacity around the digital chain and mobility of providing. Sorry, I talk a little about this thing.
What it needs to do is you need to pin or spotlight this session.
So let me say, I said about building an AI working
We're
but
not able to.
overall.
We
I got
you
building
don't have to
AI
get into
tools
it
for
for
cloud, they are the base of memories and engineering.
your brain.
Some different I will touch on that a little bit.
Look for
First
this
was
in either
the
paper
sense of often now is really affecting
or this
the choice. Okay, then if I given another money for new installation of a cluster, we are trying to get money, but still not successful so far. Hopefully next year we may have good news. The sense of hypercomputing AI convergence is here. Everywhere, top 500 of the top machines are very much GPU oriented. So Korean National Supercomputing Center is kind of say building new supercomputer. Also I say the computing power is 95% of computing power is coming from GPUs instead of GPU. Because even though they are focusing on double precision, double precision protein calculation. Yeah. But that's the sense. Okay. Now GPU is stagnating in providing major calculation power even to supercomputers. That's one thing. Another one is the scale up and down. The scale up is happening with the supercomputers. Then AI is also having the same chain. So this diagram usually explains this trend very well. So the media is they are having some kind of say actually AI or next stage cluster called the MBA ring. MBA 72. 72 GPUs are linked together in a next stage. Okay. Then the size and the kind of say the price for this one is really huge. Okay. It consumes a single reactions to 120 kilowatts. 120 kilowatts. So our can say we have a I have shown during AI cluster, since you consume around 300 kilowatts at the very moment, but this single layer consume 120. Okay. Then the price is also kind of close to the one. Dream AI costs some money, and this one single layer consume about the same amount of money. Okay. The things are now changing, scale is really happening to AI. Okay, the 72 GPUs. Okay, the what I want to say is it's really becoming condensed. So, but this is the beginning. They are talking about next version of this one, which is accumulate 72 times of thanks to 144 GPUs in a single. The next one is also 2 times of that. So maybe every 2 years, maybe 1.5 years, we have expansion of the GPU power. It's was really highly condensed ones are coming to us. And together, the water cooling and liquid cooling is coming to us. This is a really big concern. And then preparation for this is really and very much important homework to me. Yeah. And please remember all and now, yeah, right? And then obviously really high strong, you can expect this trend. Yeah. Because then you can have a race machine. Another one so which attracts our attention is so since I also kind of stay regularly attending stock building every year, it's almost 20 years now, then there are tons of especially has features, AI, yeah. So cloud is edge is over cloud, especially Python AI cloud, over cloud is kind of sensitive. Then high performance data facility. And recently very much interested in this new development in the US for the high performance data facility. Okay. Data is very much important, but still we don't have any good say what's that is a organization or is organization for organization and facility infrastructure and platforms together. They are not really mature, so US is putting effort toward the title ICDF, and I personally also believe data handling some good cloud-friendly data means the type of data facility is really important to us. Okay, so that's meant here. Okay, this sense is like this. Everywhere you can see the world and the expansion of the AI. Okay, AI, yeah, they have grown. The models are really, can say, attracting, and all this competition for building up large scale work, the hyperscale AI infrastructure is happening worldwide, which means, okay, this world is growing and growing, also data is accumulated, yes, or into the cloud, but maybe it's a hybrid cloud, right? Then how how they will this will be utilized to grow AI models, yes. Then what else? One think of the original source of data, right? All these categories, all these kind of things, as the nature and related problems about science, large facilities, and then can say infrastructure like port and the airport and those the data has to kind of generate there, maybe consumed, right? To infrastructure. Because now it's time for AI to play a role in the field. They just starting. The factories, some factories are now trying to utilize AI. So maybe for AI for manufacturing, AI for all different type of industries. It's just beginning stage, right? So then data will be generated and then consumed there with a kind of inference mode. Then will be, let's say, gathered together, and then here in the center, right? Then it will be training mode, right? Training mode and then inference mode will be connected. And then also the size of the infrastructure you may want to build, it should be kind of connected, but this connection is something we make for the federation. Federated cloud, which does link all these data together, really is very much important, right? So I personally call this one as federated entity AI or AI infrastructure over cloud is something we need to have, right? So that seems kind of the vision for me, and then maybe you may agree on this thing. So, but the problem is, okay, what kind of sense of having this thing is good, yeah, but how can you really make it happen? The real situation, real world, is quite complex thing. Okay, I have the sense of this kind of say how we can approach this real world problem and convince others to enjoy NAPOD. So, this paragraph, can you imagine this? I'm positive for this kind of parking lot is kind of shared the open parking lot. So, when you are talking about this thing, AI, and say clusters, what's happening? Okay, let me tell you the situation. Yeah, researchers who is working on AI. Okay, they are given some amount of money. They are given some amount of money. But still the money is not enough to buy so the GPUs. They are given big money because the government is say AI already very much important. You give some amount of money, then you can buy some small car with this money. Yes, but you cannot buy right size car. No, let me not call it car. It's like bus. You need a kind of bus, big size bus, in order to do AI training properly. Thinking of it, you know all this thing, right? Small cars include maybe good for your personal usage, but not for this very task, right? So So had this kind of concept talking about, okay, researchers given some money, they are buying their own car and then putting it to, say, yeah, parking lot, and then the car is not really running. The car is staying there most of the time. So that's kind of say, but the situation of, okay, having the infrastructure kind of properly built or built up in to certain size, you need to solve this challenge. Portray them. It's time to stop giving up having your own personal cars, personal GPU machines. So please give it up. So instead, we should say, okay, should I save money together and try to buy bus or this, but it's very hard game to persuade the researchers. So someone is beginning to join, but the main thing, so now, so the still buying your partner has, yeah, it's possible. It's all this air polluting thing, but if this trend of kind of say liquid cooling, the up-to-date the machine such continuing, then means keep that on because the machine you are using is not really proper to even training small models. Now it's possible, but 5 years later, no, it will not be possible. You cannot do that. Okay? Then what do you need to do? You only use your one for inference type of work, yes. It's still possible, but for training of the smaller model, so you have to utilize cloud services. Then the problem is you can cloud service, they are not affordable. Although they are not cheap, that is the point. They put a lot of things that they get price tag very big. So what I'm trying to say this is okay, having this kind of shared parking lot is important. Having shared parking lot is first thing to that because the only is electric problem. Okay, many go a bit more into this thing. If you are organization or if you're a company, things happen because of the consumption of electricity. Yeah, you cannot maintain or your company cannot provide sufficient amount of electricity to separate the server rooms. It's not possible. Yeah, our story is also same situation and all. I have this universities and then research institute for education that issue. So they are kind of having some kind of, center and say institutional kind of say small data center, yeah, to hold machine. But if you think of this thing growing, then what will happen in future, right? So please have that sense. But another important this issue with this one is data. So now researcher has to say manage data more properly. They are asked, but they cannot do that because it's too time taking and it's not also there's no essential doing it. I will use all my own data, so I just need to say with me. Okay. But now the research is becoming, like a converse. So you have to share your data with others. So then each is the right say, okay, all these things, they have some kind of say buildings, then you expect data be right together. That will be easier again, which is secured. Because securing this kind of facility is much easier, right? Because it's facility, you may put specialists working on the say security, including the data, network, computing security for everything, right? You have to take care of those. So that's required. Okay, that's the one side of having this thing, having some scale of, kind of say, organization is really required. Otherwise, you cannot play with this game. It's a really important thing. Another one, this liquid cooling is giving a lot of challenges to us. So data centers in Korea, in Finland, almost liquid cooling is just beginning. Yes, but they need to have it because AI is kind of say reading all this information, then GPUs need liquid cooling, but data centers are not ready, right? Yet. So making this one, yeah. So two type of liquid cooling, DMC and immersion. Also air assisted liquid cooling is another, but yeah, I'm there. So liquid cooling is also something important. Thanks, which I switch smart time here. Let me switch to the part data field. I made it. Okay. But one can say, can you recognize this one, right? I put this AI. You know what it means to Koreans? So Koreans, yeah, we call this small, yeah, human or small human as I. It's Korean word, like children, I. So, so this A is R and A is kind of similar, right? So this means this one is R. We Koreans we can read this as I, and this is dreaming AI. So this kind of say, so why this AI is shaped like that? This dreaming AI is louder, and okay, so data twin. I mentioned much. I already talked about this cloud native thing, the name, NVIDIA inference models, or containerized CUDA. So if you see their slide, already they are putting CUDA below, GPU and CUDA below, and then Kubernetes and the containerized. They, they are the main provider of, say, AI computer, right? But then they are saying, okay, if you want to do the inferencing, just take our link containers and then you use it. Okay, that's it. Another one they are also talking a lot is something called omnibus, data streaming, also Cosmos for physical AI. Okay, so since I only have to 4 minutes remaining, so let me just say data tweaking is very convenient for effective tool to make AI use the sense of AI useful. Okay. We have real world, we have this data tweaking. Okay. If you have this real world into data tweaking, how does it happen? It's usually data, right? Data tweaking is as data of physical space. So this data, which means AI can validate it, right? So this twin has some sense, modeling information. You will do the modeling based simulation. It's you can do some simulation of things which cannot happen in real world. It will be just there in the real world, but in the this kind of say digital world, it's just kind of simulation. Right? That's the law. So this country is very much important to validate your AI models along it, right? So the next is the main sense here. Then so NVIDIA teacher train omniverse is utilized something called USD, the universal distribution open version of OpenUSD. If they are calling our data format is in open and OpenUSD. And so there are also a lot of different applications now. The robots in the manufacturing thing is actually getting attention. Then so how they are relate to each other, and so we are also having the sense of you may hear the term physics AI, right? The real world AI, can I say into let me say also physics AI is real world situation can be generated. So I said artificial generated data, right? Artificial generated real world data through physics. It's also physical AI is yeah is now you may want to utilize it because when you want to simulate some kind of say dangerous situation, physical AI can generate it, make your model feel like I'm going through this dangerous event. Then the AI model's reaction will be tracked. Right? That is kind of say virtualized simulation. The which you will be integrated to different is very much important to us. Okay, I think I need to see this slide in very detail. So, well, kind of say so my student planning is this kind of say data tracing for the last 2 years, then some progress. So our approach for the kind of approaching our stage, the building is decently nice. And then the components thing there will be set in, and then since it's working and now it's growing, we now was able to can say here, okay, we can play with it, yeah, to some extent. Okay, this one will be really growing, it's really growing, different in factory, in the Provident factories are now spreading worldwide. It's really high cost manufacturing world. It's just beginning there, but it is spreading because we are talking about robots, right? Even humanoid style robots incorporated. Then manufacturing based, orchestration is really required. Otherwise, you cannot maintain your facility. Which means when you're utilizing AI models, okay, moving AI models, they are robots. Robots are moving AI models. When you want to orchestrate them, you need to want to have a different things, right? Okay, so I guess I need to stop here, but the next one is some homework, yeah, just for the I consume the, yeah. For 90 days because we was not able to start on time due to anyway, thanks for listening. Is there any small question? Okay, then this is all yeah.
Oh, no, this one.
Thank you for your nice presentation.
This one.
Yeah.
These ones.
Yeah. Is it it's about is it HE data, high performance data? Yeah. What does that mean actually? What is the specialty of this kind of data? High performance data, man. Okay, because all the scientific domain, you have a huge data, right? Okay. This is all the data, but you want to analyze. Okay. The same which one you're doing in the yearly scientific discovery, then you have generated experiments through the equipment, you generate a lot of data, so you need to analyze it, right? So high performance analysis is required. Otherwise, it will take too much time. All this again, every year of the talk on those, it's okay. We are stepping around the blind guider, glider, they are doing CMS, some different types of experiments. They are generating huge amount of data. But now, what we want to do is another thing, kind of say, just, timely manner, another time manner, this really high performance data analysis. But this analysis of data thing, okay, you can have some data properly organized and properly labeled and summarized some way. Then this data will be fed into your AI models. AI models, okay, you can give a data, any kind of data to your models, but then their growing or training for your model will not be efficient. You need to give very much highly consensus, organized, clean data to your models. The time to training, time for training will be significantly reduced, efficiency, right? So all these things are not there. So you mean high performance data analytics, not test? Yeah. Yeah. And high performance data is not does not yet right? Okay, thanks for listening. Yes, let's have a break and we'll meet again 10:45. Yeah.
Get Joe for the note.